Let us start with next one. That is question number 22. So, in hydrogen oxygen fuel cell, the reaction occurring at cathode is. So, first let us write all reaction that comes in hydrogen oxygen fuel cell. So, let us write all the reactions coming in hydrogen oxygen fuel cell. So, here the reaction that takes place at anode terminal can be represented as H2 plus upon reaction with OH minus, that is hydroxyl ion, which will give rise to 4 times of H2O along with 4 electrons. So when it comes to the reaction at cathode terminal, it can be represented as oxygen upon combining with water along with the gain of 4 electrons. This will give rise to 4 hydroxyl ions which is in its aqueous phase. When I write the overall chemical reaction, this overall chemical reaction can be written as 2H2 plus of O2, that gives rise to 2 times of H2O in its liquid phase. So here they are asking hydrogen oxygen fuel cell reaction occurring at cathode. So this is the reaction that is occurring at cathode, that is oxygen upon combining with water. When it gains 4 electrons, it gives rise to an hydroxyl ion, which is given by the option A. Next one, question number 23. So, which of the following is incorrect in the galvanic cell? Oxidation occurs at anode. Yes, it is true. Reduction occurs at cathode. Yes, it is correct. The electrode at which electrons are gained is called cathode. Yes. The electrode at which the electrons are lost is called cathode. So this is the wrong statement, and the correct statement is the electrode at which the electrons are lost, it is called as what? Anode. That is the correct statement. The correct statement has to be anode, but here it has been given as cathode. That is the wrong statement, which is given by the option D. Next one, question number 24. A secondary cell is one which can be recharged by passing current through it in the same direction, can be recharged by passing current through it in the opposite direction, cannot be recharged. So always it is known that the secondary cells are called as rechargeable cells. These can be recharged by passing current through it in the opposite direction, which is given by the option C. Hence, the correct answer for the question 24 is option C. Next one, question number 25. The amount of current in Faraday required for the reduction of 1 mole of dichromate into chromium ion is. Okay, let us write the reaction for this. Dichromate is given by Cr2O7 minus 2. So there is an involvement of acid in this, that is 14H plus, which gains 6 electrons, that will give rise to 2 times of chromium ion along with 7H2O. So here there is an involvement of 6 electrons, which is nothing but 6 Faradays. The amount of current required is how much? That is 6 Faraday, which is given by the option C. Next one, question number 26. By passing electric current, sodium chlorate is converted into NaClO4 according to the following equation. How many moles of NaClO4 will be formed when 3 Faradays of charge is passed through NaClO3? Okay, so they have given an equation, that is sodium chlorate NaClO3 upon combining with water gives rise to NaClO4 along with the liberation of hydrogen. When I check the oxidation number of this chlorine, this has an oxidation number of plus 5, and in the product it has an oxidation number of plus 7. So here there is a loss of 2 electrons, that is NaClO3 has lost 2 electrons to give NaClO4. By this chemical equation, it is clear that 2 moles of electrons, or I can call it as 2 Faraday charge, can produce 1 mole. 2 Faraday charge can produce 1 mole of NaClO4. Hence, or thus, 3 Faraday charge. Thus, 3 Faraday's charge will produce. So 2 Faradays will produce 1 mole, means 3 Faraday charge should produce how much? 1.5 mole, which can be represented as, thus 3 Faraday charge that can produce is equal to 1 by 2 into 3 moles of NaClO4, because 2 farad for 1 mole means for 1 farad it is half mole, that is half into 3 moles of NaClO4, which is nothing but 1.5 moles of NaClO4, which is given by the option C, that is 1.5 moles.